Now we will do a second example of answering the for loopy questions. In this example, the precondition Q, postcondition R, and loop invariant P are given as pictures. This time, we will develop the initialization and loop using the for loopy questions. To help you remember the for loopy questions, here is a general flowchart for a loop, including initialization. In it, this is the initialization step. While B is true, this is the loop condition, do S. This is the loop body. Now let's look at the example. In precondition Q, the question mark means that we don't know anything about the values in the array segment b sub 0 ... k. The purpose of the algorithm we are going to write is to rearrange the values in this segment so that the postcondition R is true. The postcondition tells us that we are supposed to put all of the non-positive values on the left and all of the positive values on the right. Note that the algorithm is not allowed to change k. The algorithm does not necessarily deal with the entire array, only with the segment b sub 0 ... k. Remember that by the follower minus first rule, this segment contains k plus 1 elements. It is these elements that the algorithm will rearrange. We will use the invariant P shown here. It is a generalization of the pre and post conditions. Now let's answer the for loopy questions. The first question is, does the algorithm start right? We want to show that the initialization makes the invariant P true. In other words, does the execution of the initialization with Q true terminate with P true? We need to figure out what the initialization should be. Our goal is to find the initial values for variables h and j. Another way to think about this is that we want to make the diagram for P look like the diagram for Q. Initially, every value in the segment is unknown to us. We don't know if any given value is positive or non-positive. So, the entire segment should be covered by the question mark region, as it is in precondition Q. In other words, the segments b sub 0 ... h minus 1 and b sub j plus 1 ... k in diagram P must both be empty. These segments will be empty because we don't know for sure any values that should be classified into either of these regions. Using the follower minus first formula, we will set both segments to contain 0 elements. First, h minus 1 plus 1 minus 0 must equal 0. Likewise, k plus 1 minus j plus 1 must also equal 0. Solving these equations gives us that h equals 0 and j equals k. Remember that k is given to us, and we are looking for j's initial value. So the initialization is h becomes 0, j becomes k. This initialization, with q true, makes p true. The second loopy question is, does it stop right? In other words, does the invariant P combined with the opposite of the loop guard, B, imply the postcondition, R? The loop must end with R true. To make invariant P look like R, the unknown segment, B sub h ... j, must be empty. Using the follower minus first rule, we can see that B sub h ... j is empty when h equals j plus 1. Note that if h equals j, then the segment still contains one element. it would not yet be empty. So when b is false, h equals j plus 1. In other words, not b is h equals j plus 1. This implies that b should be h does not equal j plus 1. We have found our loop condition b. Combined with the invariant, the negation of b implies r is true. The third and fourth loopy questions we will do at the same time. Does the loop body, or repetend, make progress toward termination and keep the invariant true? The repetend will get closer to termination by reducing the size of the unknown segment b sub h dot dot j. That means that on each iteration, at least one element from the question mark region must be moved to either b sub 0 dot dot h if it is non-positive, or b sub j plus 1 dot dot k if it is positive. Let's see how to do this. We will look at the element b at h. This element is either positive or non-positive, and we should do something different in each case. This calls for an if statement. Let's examine what happens in each case. If b at h is less than or equal to 0, then we should place it in the leftmost segment. We can do this by simply incrementing h by 1. This is done with the statement h becomes h plus 1. In the other case, when b at h is greater than 0, the element in question belongs in the rightmost segment. We move it there by swapping the elements at indices h and j, and then decreasing j by 1. Note that in this case, we do not increment variable h, since we have not yet looked at the element now contained there. We have satisfied the last two loopy questions. This yields the algorithm shown here. We have used the loopy questions to develop the initialization, the loop condition, and the loop body. We know that the algorithm is correct because we have satisfied all four loopy questions.